Hello friends, this video has been prepared by the Technical and Services Department of Kaliyakot College Engineering Limited to impart training to process engineers to balance the heat of process side and the cooling media side of a heat exchanger. When designing a heat exchanger, the basic data required for to be a basic data which a designer or manufacturer of heat exchanger requires are given in the next slide. Yeah. Flow rate of the cooling media, inlet and outer temperatures of cooling media, flow rate of process fluid, inlet and outer temperatures of process fluid, average densities of tube fluids within the operating range, and average specific heats of the tube fluids within the operating range. The average densities and this average specific heats are well known, and it can be taken from any table from any standard sulfuric acid books and or any chemical engineering book. Flow rate of cooling media, and out of the six data, that is flow rate of cooling media, inlet and temperatures of cooling media, flow rate of process fluid, inlet and outer temperatures of process fluid, and out of these six parameters, at least 5 parameters are defined by the client, and 6 parameters is achieved achieved by calculating the process side of heat of cooling media and this process fluid, which is to be cooled, and cooling media which gets heated up. Yeah, this is the basic calculation. Inlet temperatures, cooling media, process fluid, and flow rates, densities, and a flow rate in kg per hour, specific heat, heat generated, and heat balance, heat duty. This is Kw is achieved. In inlet, you can see this. These are the rows: row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and column A, B, C, D, E, F. Now, T1, T2 are inlet. Sorry, T1, T2 are inlet and outer temperatures of cooling media, which comes in the heat exchanger at lower temperature and leaves heat exchanger at high temperature. Process fluid enters the heat exchanger at high temperature and leaves it at lower temperature. Flow rate, volumetric flow rate of two fluids, density. So the flow rate per kg defined as B6 and into B7 into 1000, then it comes to kg per hour because that is in kg per m cube. And same way C6 into C7 into 1000. Specific heat kilocalorie kg per degree centigrade is H1, small h1 and capital H1. So heat generated is this is B8 into B9 into B5 minus B4 because B5 is high temperature. Same way C8 into C9 into C4 because C4 is high temperature, C4 minus C9. So we get this data we get as B10 into F3 because the general practice is to express the process heat of exchanger as a heat duty, which is calculated in terms of kW. So this is standard conversion table. 1 kilocalorie is equal to this much of kilowatt. So heat duty of cooling media side is B10, this value into this value F3, and for the process fluid side it is C10 into this value. In most of ideal conditions, and if a required process data supplied by the client are correct, then B11, that is this value, should be equal to this value. If these are not equal, these values are not equal, it means there is some flaw in the data collected. So before designing heat exchanger, first process heat is to be balanced. When process heat is achieved, by balance is achieved, then only mechanical part of the design starts. Okay. Now, thank you for your patient hearing. Now, You can ask any questions. Thank you.